Hello, and welcome to the Lesson 9 example. This is the first of two. Please make sure you have read all the directions or use the microphone to listen to the directions as you read along. Also, please make sure that you pause the video every few minutes to make sure that your notes are up to date with mine. And what's different about this one is I'm going to actually ask you to do some of the work ahead of time once I get you set up. So you'll pause the video and continue the work a little bit and then check to see if you're on the right track. So in this problem, after you've read it, you should have seen that for every is our ratio language. It lets us know that this problem is about a ratio. So I'm going to underline that. And then other key information is the 2 cups of water and 3 cups of flour. And so I would select that text and choose the highlighter next to these letters. Again, remember that the highlighter color should be one of these 3 so that it's easy to read. It stands out, but it's not removed from the text. There we go. And the same thing for this one. And it could be the same color or different color. I'm going to put a different color just because they're 2 different numbers and I want to be able to keep track of them, but it's up to you. So then the information that we're given is technically this sentence, but we should be interpreting it, not just directly writing down exactly what's there. So I'm going to say, well, because of the for every language, there's a ratio. So ratio of water, actually cups of water, so cups of water to cups of flour equals 2:3. So we have a ratio. It's comparing cups of water to cups of flour, and it's 2:3. And so then that comes down to the next piece where it says to find equivalent ratios of the cups of water. We'll highlight that, to the cups of flour. We'll highlight that. All right. The word to could also be highlighted if you'd like. So now we're going to represent this ratio in multiple possibilities. So right now we see only one possibility, 2:3, but there are other possibilities. Like what if this art teacher, Ms. Rodriguez, for example, doubles the recipe? The consistency will still be the same of this paste, but it'll be more. And if she's doing it for a whole class, she might actually need more than just 2 cups and 3 cups. So we're going to fill in first the label. So this is cups of blank. Well, we already have water here, so that means it must be flour. So I'll type in flour here. And then we can put the original ratio. So that's 2 for water and 3 for flour. And then we're going to identify a couple of things about this ratio. First of all, the C value. A C value is the multiplier from the original ratio. And so if I'm putting this here, it's the first one. And so that means I'm basically multiplying it by 1. So C equals 1. And that's because 1 times 2 is 2, and 1 times 3 is 3. So the original ratio multiplied by 1 each is 2:3. The second part is the value. And the value of a ratio is its fraction form simplified. And so for this one, it's going to be 2/3. All right, let's go on to the next one. So if C equals 2, that means I want to double my numbers. So if I double this number, that would be 2 plus 2, that's 4. If I double this, then that's 3 plus 3, which is 6. And so then the ratio value would be 4:6. I'm going to write it down here, 4:6. And the reason for that is that I need to, when I put it here, write the simpler form. I could put both. I could say that the original form equals the simpler form, and we'll show that right now. So if I think about what makes 4 and 6, well, I just multiplied each of the original numbers by 2 to get there, and so I'm going to divide by the C value. And if I divide by the C value, the number of 2's that it takes to get 4 is 2, and the number of 2's it takes to get to 6 is 3. And so right here, I'm going to say 4/6 equals 2/3. Those are equivalent. And that also shows that these are equivalent. The values of the ratios are equivalent. Now I encourage you to fill in the rest of the C values and to fill in the rest of the numbers here. Pause the video, and then at the end of that video, or at the end of the time that you have to fill in the table, we're going to check in and see if we're on the right track. Okay, so hopefully you paused the video because now I have answers for the C values and for the work. If you did not do that, I would recommend pausing the video for a moment, go back and do your own work, and then come back and see if it's on the right track. If your numbers agree with mine, then you can keep them. If your numbers disagree, then maybe you made a miscalculation and you can fix those. I'm now going to talk about the last piece of the ratio value. So I already put a new one here. 6 to 9 is the same thing as 6/9, and that will simplify to 2/3 if I divide both of the numbers by the C value. So it shows that it's still equivalent. Now we're going to do the next one. So the ratio is 8 to 12, so that's 8/12. And if I divide both of them by the C value, that's the common number that makes both of them, then I would end up with 2 to 3. And I'm going to do the last one, and that's the one that I'll prove over here. So 10/15 is equal to something. So 10/15, I could look at the C value, or I could just think about what makes 10 and what makes 5. Well, to get to 10, you can multiply 2 times 5. And to get to 15, you can multiply 3 times 5. Since 5 is that common number, I'm going to use 5 in the giant part. It's called the giant one in other lessons that I've done before. I'm going to actually have it blue for you when you do it. And so then the final fraction is 2/3. So we can put that in here. And make sure that the slash goes the correct way. We don't want the slash to be going like leaning forwards onto the first number. It needs to lean back. So it looks more like what we would expect a fraction to look like. Now what we're going to do is make sure that we've done everything we can and then kind of wrap up the problem. So the first thing is part C says to label each equivalent ratio with the value of C that is used to create it. C stands for constant, or like unchanging. So this is the constant number that made this ratio from the original. This is the constant number that made this one, because you use the same number both times. That's what makes it constant. You didn't change the number when you multiplied. You multiplied both of the original numbers by 2, both of the original numbers by 3, and so on. So we've already done that. Next, write a question that could be answered with this information. All right, so one of the things about ratio tape diagrams, or tables in this case, is the goal is not to create them, but to use them. They are tools to help us to solve problems. And so I want us to think about some different questions that someone might ask based off of having to create this table and using it to solve. Most likely they would be thinking about something kind of towards the bottom of the table. Otherwise, there wouldn't have been a point to going that far. But it also might be helpful to think about going beyond the table and thinking about, well, if we got to 10, couldn't we get to 20 or to 30 using the same process, or even like skip counting straight down to there? And so these are 3 different possible questions. If you look in the teacher notes, there are 3 possible questions, and you can choose any of those 3, and you're going to copy it in here. So the first one is that if Ms. Rodriguez uses 10 cups of water, so that's right here, how many cups of flour should she use? And so someone looking at the table after they made it would be able to solve that. They'd be able to say, oh, well, that's in this ratio right here, the bottom one, and so that would help me to answer the question. And I'm going to go ahead and highlight these. You don't need to highlight them, but I'm just showing that these connect to that question. Okay, so then another question that you could type, so instead of that one, you could choose a second question. And this is not a question you're going to be answering, it's just a question that we're asking ourselves. If Ms. Rodriguez uses 12 cups of flour, so here's cups of flour, go down to 12, then how many cups of water should she use? Based off of the table, it would be 8. All right? All right, so you could choose that one, you could type that one, or you could also copy and paste or type the third question. So if Ms. Rodriguez uses 20 cups of water, how many cups of flour should she use? Well, that's kind of like this row, except double, like twice as far down. And so someone could say, oh, well, if this is 10, then I double it to get to 20. So if this is 15, then I would double it to get to the answer of this question. So this is just for us to think about what are some types of questions that someone might ask as you are solving these questions. So you could choose any of the 3 that I have highlighted down in the teacher notes, and you can copy it into here. The last thing is, what is the simplified value of each ratio? Well, the simplified value is the ratio value here, and it's the simpler version of each one. So all ratios have the simplified value equal to 2/3. So all of them equal 2/3 once you simplify them. They might not look like it at the beginning, but they all simplify to 2/3, and that's super important for ratio tables, that they all have the same simplified ratio value. All right, well, I hope that this was helpful. I will see you in the next video.